Assalamu alaikum. This is Muhammad Khuram, and in today's lecture we will discuss the how can we plot a trigonometric function. Basically, this lecture series is depending on a sixth lecture, okay? But in today's lecture we just discuss how can we plot a sine function. First of all, we visit our lecture outline. First of all, we discuss how can we plot a sine function, phase shift, amplitude, period, and vertical shift. These are the topic we will discuss in our today's lecture. First of all, we will discuss some terminologies which are used in our today's lecture. Period. Basically, when we are talking about the period is just like, for example, the distance between the repetition of any function is called period of a function. Basically, our trigonometric functions are a period. We will prove later, but let's say in this definition, for a trigonometric function, the length of one complete cycle is called a period. For example, when we are drawing some graph of a function, basically the periodic function is let's suppose this f is a function, and f is a periodic function if f of x plus let's suppose this is not x, if this is, I just write here, this is p plus x, where p is their period, okay? P plus x is equal to f of x. This function is called periodic function because p is their period, p is the period of this function, and after this period our function repeats its value, okay? For example, you notice here, when we are talking about the trigonometric function, you notice here, if sine theta, I just use a sine theta because over today's lecture totally depending on sine theta, okay? So if sine 390, okay, sine 390, so sine 390 can be also written as sine 360 plus 30 because the period of a sine and cosine function is a 360, okay? So we separate the period, we can write it as sine 360 plus 30, okay? Sine 360 plus 30. So you can notice here, because the 360 is the period of this function, so we just write here sine 30, which is similar to the sine 390, okay? Sine 3 is equal. How can this is same? I just draw a graph and understand how it is. How is it same? Okay, sine 30. So basically, look here, a complete rotation is equal to 360 degree. If this, notice here, this is a 0 degree, this is a 90 degree. If we are moving in the anti-clockwise direction, this is a 180 degree, and this is a 270, and finally we reach at the origin position, which is called 360 degree, which is a complete rotation, okay? This is 270 and finally the 360, okay? This complete rotation is 360 degree, okay? You notice here 390 is somewhere here, okay? The 390 is somewhere here, and this angle is a 30 degree. This is a 30 degree, okay? And if we start the position from here, you notice here, when we are reach at this point, over rotation is 360 degree, and when we added a 30 degree more, we get a 390 degree, okay? So notice here, this is called a periodic function. Our function repeat its value after a certain interval, okay? And graphical representation we will see in our next slides, okay? So the period is a function which repeats its value after a certain interval. This interval is called a period, okay? So what is the amplitude? So basically, the amplitude of a function is the amount by which the graph of a function traveling above or below its middle line. For example, you notice here, when we are talking about the middle line, so it's mean and this is some xy coordinate, and you notice here yeah, very good. And if this is a over 1 and this is over -1, okay, so you notice here our function, the height of our function is above and below of this middle line is 1 units. Okay, my graph is not perfect, but this is the actual meaning of this amplitude. Okay, this is our middle line, this arrow line is your middle line, and the above and the below of this function is same. Okay, from 1 to -1. This is called the amplitude of a function. Okay, next the periodic function. Obviously we are already discussed the periodic function is a function which repeats its value after a certain interval, so that's why we can say that. So this is a definition of a periodic function we already discussed here. And so all the trigonometric functions are periodic function because it's repeat its value after a certain interval. For your kind information, I just share the period of a 4 trigonometric function: sine, their inverse, sine their reciprocal, cos their reciprocal, okay, is 2 pi, and tangent and their reciprocal has a period pi. Okay, so and this is a figure which emphasize over the amplitude and a period. Look here, the period is basically the distance between two highest point or two peak points or to a minimum point. For example, if you start your distance from here, and when you reach after covering this whole distance at this point, this is your complete period. Okay, and if you starting from here, okay, your period is at here. When you complete this rotation, look here, when you starting from here, here and here, okay, this is your period. Okay, the period is totally depending on your starting and ending point. Okay, and the amplitude, because this is your middle line, this dotted line is your middle line, and the above this dotted line and below this dotted line is your same distance, and this distance is basically called amplitude. Okay, this is your middle line. Okay, so now we are the general form of a sine function is basically we can write the sine function in this way. Okay, y is equal to a sine bx plus c plus d. Okay, in this case this a represent the amplitude, c represent your phase shift, and d is represent your vertical shift. Okay, and a represents your amplitude. Obviously find the phase shift by using, you can finding the phase shift by using this bx plus c is equal to 0. Okay, and you can easily find your phase shift. Obviously your phase shift, when this sign is positive, your phase shift is c unit left, and if this is negative, you are c unit right. Okay, and d is a vertical shift. The period, you can find the period by using this formula. If you are talking about sine, cosine, cosec and secant function, okay, you always use this formula to finding the period, 2 pi over b. Okay, this is the formula for finding the period. Okay, as we can know, the sine and cosine and their reciprocals has a period 2 pi, that's why we can write here 2 pi over b. But when we are talking about the tangent function, then their period is pi over b. Okay, so step 2, plot a graph. How can we plot which step we follow to graphing a sine function? If we have a function like y is equal to sine x, okay, first of all we just compare this given function with the general form. When we are comparing in our general form, we notice here our amplitude is just 1. Okay, and our phase shift is 0 degree to a left and a right, because in this case c is 0. The value of b is 1. Okay, and the vertical shift is also a 0 degree. Okay, in this case I just write here the amplitude is 1, period is 2 pi over b, because the value of b is 1, that's why we can write here 2 pi over 1, which is 2 pi is our actual period. C is equal to 0, it's mean the phase shift is 0, and the vertical shift is d is also 0, that's why the vertical shift is 0. Okay, now notice here we just draw this one. We already know the period over period of a sine function is 2 pi. Okay, 2 pi, it's mean 360. You can use both notation, either it is a degree notation or a radian notation. Okay, this is a 0 degree, this is a 2 pi, and in the middle of 0 and 2 pi 180 degree, which is a pi. This is a pi over 2, and the difference between these two is 3 pi over 2. Okay, and here 3 pi over 2, 3 pi over 2. Okay, so the over sine function at 0 over sine value is always 0. At pi over 2, so over amplitude is 1, so that's why over function is 1 unit above and 1 unit below. Okay, so this is a negative one and this is a positive one. Okay, I just write here, this is a 1 and negative 1. Okay, this is a 2. Okay, so when over function is 0, over sine function has a minimum value. At pi over 2, over function has a maximum value, which is 1. At minimum, at pi, over function is again 0. At 3 pi over 2, over function has the negative value is negative 1, and at 2 pi over function reach at again 0. Okay, so we can join this point by using a smooth curve. Okay, and this is a curve. You notice here this is over amplitude. Okay, this is over amplitude, and if we are starting from here, and this whole thing is over period. Okay, we are starting here and ending here, this is over period. And when we extend this graph like 2 pi plus 90, 2 pi plus 180 and something like that, all of this graph is a reflection of this graph. Okay, either we are moving in a negative direction or either we are moving in a positive direction. Okay, so all of this graph is a just reflection of this graph. That's why we just take a one interval and draw a graph for that interval, and all of the other interval is the reflection of this interval. Okay, now we are moving on a next equation. In this case, you notice here the over question is y is equal to 2 sine 3x plus 60 degree. Okay, first of all we compare with the original equation. You notice here the amplitude is 2, the period is 2 pi over b, because the b value is 3, that's why 2 pi over b, which is equal to 2 pi over 3 or 120 degree. Okay, when you are using a radian notation, you just use this one. Okay, and if you are interested to solve this one a degree notation, this is a 120 degree. Okay, and your horizontal shift, look here, your horizontal phase shift is 60 unit negative. C is equal to 60, so phase shift 3x plus 60 is equal to 0, so it's mean 20 degree negative direction. Okay, 20 degree shift to a negative direction. When you are solving this one, you subtract 60 degree on both sides and dividing 3 on both sides, you get x is equal to negative 20. Now look here, when over graph in a standard position, over period is 120. Okay, now our function moving 20 unit left. Okay, it's mean we subtract 20 from 120, 20 from 120. Okay, and when we subtract, because we are moving left 20 unit. Okay, if we are moving right 20 unit, we added 20 unit in over period. If we are moving left from left any unit, we subtract from over period. For example, in this case we move left 20 unit, that's why we subtract a 20 unit from over period. Okay, and we get a 100 degree. Now over period is 100. Okay, now in positive from over period, repeat every year 100 degree. Okay, for example, this is a graph. Okay, we may move a negative 20 degree. Okay, over graph is not in a standard position, not is at origin. Okay, we are moving 20 degree. Here is a some 0. Okay, and at 100 degree over graph, repeat its value. Okay, when you are counting from here, your actual period is 120, okay, but when we are talking about above the 0, our period is 100, okay. When after along this direction our period is 100, but when we are starting from here our period is again 120 degree, okay. This is a 20 degree, this is a 100, this is 0, the middle is 20 and 100 is somewhere 60, okay. The 60 and 40 is somewhere 30. No, I think here this is a 30 degree, and this is a the middle of this is a 80 degree, okay. Okay, this is a 80 degree. Now if you plot this if you are plotting this graph, you notice here your graph is no, this is 20 plus 100 is 120 is, I think this is a 20, we are using a 20 40 60 80 and 100, okay. This is a 20 20 20 gap, okay. At 0 negative 0 your function is 0 degree, okay. At 40 now your amplitude is 2 units, okay. You 2 unit above and negative 2 unit below, okay. Notice here at 40 degree your graph is at maximum position, okay, at maximum position. At 60 degree your graph is again at a 0, and at 180 degree your graph is at negative 2, and again at a 100 degree your graph reach at a 0 position, okay. So look here, this is a complete period, okay. You are starting from negative 20 and 100, you complete its period, which is 120 degree, okay. From 0 to 100 is 100 degree plus 20 is your 20 degree, okay. So the last question of this lecture is 3 sine 2x minus 90 plus 2, okay. Compare with the original equation, you just find the amplitude is 2, period is 2 pi over b, because the value of b is 2, so our period is 180 degree or just pi radian. You use any one of notation, and the next phase shift is negative 90, okay. So just put 2x minus 90 equal to 0, and you just find you are moving 45 degree to right, 45 degree to right, okay. But notice here the important thing is here, if the period the vertical shift is 2, notice here now your line is not at 0, your line is at, for example, this is your original 0 1, and this is 1, this is 2, and this is negative 1, this is negative 2, and this is 3, okay. Now you are moving 2 unit up, so your line is this one, okay. Now your original line is this one, your graph shifting 2 unit above. Now what is your period? 2 plus 3 is 5, okay. 2 plus 3 is 5, so your period is 5 and 3 unit below, 1 unit, 2 unit and negative 1, okay. Now your period, now your amplitude is 5 and negative 1 is your amplitude, okay. Now your amplitude is 5 and negative 1, because your graph is shifting 2 unit above and your amplitude is also changed, okay. If your graph is at original position, your amplitude is 3 and negative 3, but your graph is shifted 2 unit above, now your amplitude is also changed, okay. Look here, I also write here in my slides, now the amplitude is 5 and negative 1, okay. This is the formula for finding the amplitude, okay. Because the graph is shifted 45 degree rights, okay, and our original period is 180 degree, so you just add 140 plus 140 180 plus 45, and now your graph is extend from 225 degree, okay, because you are shifting 45 unit right. Okay, now we are drawing a graph here, and this is a 245 degree, and now we are shifting 45 unit right. Okay, 45 unit right, and for 180 plus 45 is 225. Very good, it's a 225. Well, and the middle of this 225 and 45 is, I think so, 135, obviously, and the middle of 45 and 135 is just 90. Well, and the middle of 135 and 225 is 180. Okay, so the gap is just 45 degree. I just use a gap of 45 degree. Okay, no, you are starting from 45, not 0. You are starting from 45. But first of all, I just 1 2 3 4 and 5 unit. Okay, this is a 5, this is a 4, this is a 3, this is a 2, and finally 1. Okay, -1 and -2. Okay, but important thing is here, now your the original line is this one, but your graph is shifting 2 unit above, so your line is this. Okay, you follow this line, this red line. Okay, not blue line. Notice here, now if you follow this line, what is 3 unit above? Move 3 unit above, because your amplitude is 3, 1 2 and 3, so your graph is moving above from 5 unit and moving 3 unit down, 1 2 and 3, and the minimum point is -1. Okay, so your graph is oscillate between 5 and -1. Okay, at 45 degree your sine function is 0. Okay, I mark it 0. At 90 degree your sine graph is at maximum point. Okay, at 135 degree your graph is again at 0, and at 180 degree your graph is at -1 minimum point, and at 225 you are reach at a origin position, and you just join this graph by using a smooth line. Oh, I'm really sorry for that. Okay, this is starting from here, and at 135 it's again intersect the x-axis, and this one is our graph. Okay, so this is our graph of a function. Okay, hopefully you are understand this concept and enjoy this lecture. Okay, if you have any problem, then you can contact with me and discuss your query with within a comment section. Thanks for your attention. We will see you in your next lecture. Allah Hafiz.